Let's talk about how we balance a redox equation in acidic solution. So we've got permanganate and oxalate forming manganese 2 and carbon dioxide. First thing you need to do is go through and assign oxidation numbers. Oxygen isn't changing, so we're ignoring it. So manganese goes from +7 to +2, so that means it's getting reduced. And carbon's going from +3 to +4, so that means it's being oxidized. So here's my oxidation half reaction. Right, oxalate is becoming carbon dioxide, and it goes from 3 to 4, which means it lost 1 electron. But we've got to balance the carbons, right? There are 2 carbons on the reactants and only 1 carbon on the right. So we need a coefficient of 2 right here. So if 1 carbon loses 1 electron, then 2 carbons lose 2 electrons. And now my carbons and my oxygens are all balanced, right? 2 carbons on the left, 2 carbons on the right, 4 oxygens on the left, 4 oxygens on the right. For the reduction half reaction, manganese is going from +7 to +2, so that means that it gained 5 electrons. Now notice on the reactant side we've got oxygens, but there are no oxygens on the product side. Because this is occurring in an aqueous acidic solution, we can add as many H2Os as we want, right? Because water's the solvent. So the way we balance the oxygen is by adding H2O. So there are 4 oxygens needed, so I just write +4 H2O. But now there are no hydrogens on the reactant side. Where do those hydrogens come from? This is acidic, so that means that H plus is what I'm adding. I need 8, right? 4 times 2 is 8. So 8H plus added to the reactant side. So now there's my balanced reduction half reaction. Next we're just going to add them up. The number of electrons in the reduction is 5. The number of electrons in the oxidation is 2. So I'm going to turn them both into 10 so that they'll cancel out. So multiply the oxidation half reaction by 5, multiply the reduction half reaction by 2. My electrons cancel out, and there's my final balanced redox equation. They get kind of long, but that's okay.